So students, we are doing the C part of current electricity. Again, it's a very simple part, and there are a lot of numericals in this part of the chapter, and there are just a few 3-4 definitions are there, that's all. But the numericals in C part of the chapters, they are much simpler than what you've done in the A and B part. Okay, so now see, we know there are different forms of energy, like you have current, electrical energy, sound, heat, mechanical. But out of all these forms of energy, one of the most important form of energy is considered to be electrical energy. Why is electrical energy so important? Because you can easily convert it from one form of energy to another form. Like I can convert electrical to light, electrical to heat, electrical to sound, electrical to chemical. So you can convert from one to another form very easily. Now in this part of the chapter, we have to learn about what do you mean by power rating. So you must have seen, on many of the appliances now, if you check the appliances, they always mention the power rating of that appliance. Like when you buy a bulb or anything. Let's say for example, there is a bulb whose power rating is 100 watts, 220 volts. Now what does this mean? It means that this bulb needs a potential difference of 220 volts and its power is how much? 100 watt. So in India, basically the potential difference is 220 volts for all the appliances. So if you want to use any appliance in India, you have to have a potential difference of 220 volts. Now it may happen so that now what do you mean by 100 watt? 100 watt means that the energy consumed by an appliance will be 100 joule per second. It means that appliance will consume 100 joule of energy every second when you are using it at a potential difference of 220 volt. Now let's say the required potential difference is what? 220 volts, but let's say you're working somewhere or in some place the potential difference becomes 300 volts. Now is this good or bad for your appliance? It is very dangerous for your appliance if the potential difference increases drastically to 300 volts. Why? Because when the potential difference will increase, it will also give out more power also to the bulb. So say it is giving a power of 150 watts. So now a bulb which was designed to consume 100 joule every second will now try to consume 150 joule every second. So because you are giving more energy than its capacity, there are chances that filament of bulb might melt. Okay. Now even the other way around is possible. It is possible that you are in a place where the potential difference falls to say 100 volt. Okay, even this is not good. Okay, it is not dangerous for your appliance, but it is not good for your appliance to work. Because with this potential difference, your appliance will not be able to work only properly. For example, if you are using a bulb at this 100 volts, the same bulb now will not glow brightly. It will be dim, like it will not give you enough or sufficient light. So when the potential difference decreases, note that the power of the bulb will also decrease. So it is how much? Only 60 watts. So since it's giving only 60 joule of energy per second, and that's why your potential difference also becomes, the power the bulb is getting also becomes lesser. Okay, now so make it clear that you always need the same potential difference for the appliance to work. 220 volts is what we need in India. If you go to other countries like say US, there the potential difference is 110 volts throughout. So you cannot use appliances bought from US directly here in India. You need an adapter for it. So you must have noticed whenever you buy an Xbox from there, you need another connector or an adapter. Then only you are able to use it. Okay. So they may ask you in exam, what do you mean by power rating of 100 watt and 220 volts? So you have to just state that it means that an appliance will consume 100 joule of energy every second. Okay, when the potential difference is 220 volts. Now now the basic formulas what you need in this. The first formula is Varun Iyer, second is never quit. meaning Q is equal to IT. So if you remember, Q is the charge, I is the current, and T is the time. Next thing, now there are some more formulas for how to find the power. So when we say power out here, we mean electrical power. So the first formula is P equal to V into I. Now what is V equal to IR, right? So in place of V, we'll substitute IR and into I. So I squared R. Okay, third formula, what is I equal to now? So I is equal to V upon R. So in place of I, we will substitute V upon R. So now your formula becomes P is equal to V squared upon R. Now, if you remember, what is the formula for energy? Energy is equal to power into time. So if I multiply all these formulas of power with time, I'll get the formula for what? Energy. So look at the first formula, it will become VIT because power into time. Your second formula becomes I squared RT, and third formula is V squared T upon R. Okay, now so in the out of all these three formulas, okay, so you'll have to learn all the formulas, and you can copy down if you want right now only, or you can take a screenshot and then copy it in a notebook later on. Now one more thing, that there is something called as a commercial unit. So when they calculate your electric bills, they calculate on the basis of commercial unit. Now what is a commercial unit? So commercial unit is what, the unit in which they calculate your electrical energy consumed in the unit kilowatt hour. So kWh means kilowatt hour. Now 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1 kilowatt is how many watts? 1000 watt. And an hour will have how many seconds? 3600 seconds. So when you will multiply, you will get 36 lakh joule. Okay, you can cancel second on both. So you'll get 36 lakh joule. You can also write this as what? 3.6 into 10 raised to 6 joule. So kilowatt hour is basically the commercial unit of electrical energy. They may ask you 1 kilowatt is how many joule, or they can also ask you to derive it. There is one more unit which is not a commercial unit, but still even that unit is used sometimes, which is called as watt hour. Okay, watt hour means what? W into H, watt hour. Now how to derive for watt hour? So 1 watt hour is equal to 1 watt into 1 hour, but 1 watt is 1 joule per second, 1 hour is 3600 seconds. Now if you multiply them, you will get 3600 joule. So they may ask you to derive this also, 1 watt hour. Okay, they can also ask you to define 1 kilowatt hour or 1 watt hour. So 1 kilowatt hour, if they ask you to define, you have to just state that 1 kilowatt hour is the energy consumed by an appliance of power 1 kilowatt in 1 hour. Also, this formula of energy I squared RT is also called as Joules Law of Heating. It's called as Joules Law of Heating, Joules, Joules Law of Heating. So according to Joules Law of Heating, whenever you will pass current through the wire, okay, when you are passing current through the wire, so let's say when you're passing the current through this wire, then the energy produced is directly proportional to the square of the current. It's directly proportional to the resistance of the conductor and directly proportional to the time for which you are passing the current. Okay, so Joules law is given by the formula I squared RT. Okay, now Okay, one more very important concept, the resistance of an appliance will always remain constant. So the resistance of an appliance will never change. So whether you use it at a higher potential difference or at a lower potential difference, the resistance of that appliance will never change. So we'll start the numericals of page number 212. Okay, so the sums are very easy. For every problem, you can read the problem first yourself. I'm just writing all the data and I'll write the formulas on the side too, how to solve them. So now the video will go on mute. You will not hear me. Okay, I'm just showing the working. So wherever you want, you can keep doing pause, play and keep on solving the problems. Okay, so I'm solving some of the problems, some I've left in between. Just I've given the hint over there because some of them are easy problems. Still, if you're not getting something or if you have doubts, then we'll discuss it in the class.